Okay, this is the P2 paper from January 2024. It's question number 5. This is a sequences and series question. We've got sigma notation here. We've got some recurrence relations. We're going to have some work to do with geometric series and sum to infinity. But let's make a start. Let's do A part 1. So it says, can we find the sum r equals 1 to infinity of 6 times 0.25 to the power of r. So the sigma notation means that we're going to put 1 in, we're going to put 2 in, we're going to put 3 in, we're going to put 4 in, and we're just going to keep adding all those values together. And we're going to do it from 1 to infinity. So there's a big clue there, sum to infinity. That always works out with our geometric sequences. But let's just do it. So if r was equal to 1, I'd have 6 times 0.25. If r was equal to 2, I'd have 6 times 0.25 squared, and so on. I'm sort of doing way more than I need to do for this bit here. So if we get those values, that's going to work out to be 3 over 2, and this is going to work out to be 3 over 2 times 0.25, and then 3 over 2 times 0.25 squared. So I can see that this is a geometric sequence AR squared, and if we are adding those together, we are trying to find the sum to infinity. So we're trying to find the sum to infinity, which is a over 1 minus r, and in this case a equals 3 over 2 and r clearly equals 0.25. So the sum to infinity is going to be 3 over 2 over 1 minus 0.25. Stick that into the calculator and it comes out to be equal to 2. So the value of that works out to be equal to 2. Second part, we've got this recurrence relation. U1 is equal to 3. And then remember what recurrence relations are. The next term is always, in this case, 3 minus 3 over 3 minus 2. Put your value in for u to the n to work out what u to the n plus 1 is. Easy if we actually go about doing it. So this is A part 2. So A part 2. We've got u to the 1. I would always write those down. First of all, u to the 1 equals 3. U to the 2 is u to the n, so that's 3 minus 3 over u to the n, so that's 3 minus 2. Well, 3 minus 3 on the top is 0, isn't it? So that's going to work out to be equal to 0. U3 is going to be putting that value in, 0 minus 3 over 0 minus 2. Well, that works out to be 3 over 2, or 1.5. Put that value in for U4. So U4 works out to be 3 over 2 minus 3 over 3 over 2 minus 2. And that jumps us back to 3 again. So you can see our values, 3, 0, 3 over 2, 3. So if those are our values, 3, 0, 3 over 2, 3, we can see that that's just going to keep repeating from that moment onwards. So part A said, show the sequence is periodic, and we've done that. Just say, therefore, sequence is periodic. Okay, we just got that repeating every time. And part B said, state the order of the sequence. So the order of the sequence, how many terms do we have before it repeats, is 3. And then the last part, part C, says, okay, from that, can we find n equals 1, the sum of U1 plus U3 plus U4 all the way up to U70, U2 plus U3 plus ... all the way up to U70. And we do this a lot with periodic functions because, yeah, of course we can. It's basically going to be 3 plus 0 plus 3 over 2 plus another 3 plus 0 plus 3 over 2 and you'll just keep going on with those until we get the closest multiple of 3 to 70, which is the 69th one. So we'll get 3 plus 0 plus 3 over 2. This is the 67th, 68th and 69th terms. And then U70, well, just following the pattern through, must be 3 there. Okay, how many lots of those are we going to have? Well, if I've got 69 terms there, 69 divided by 3, it's 23 lots of 3 plus 0 plus 3 over 2 plus our 3. And 3 plus 0 plus 3 over 2 works out to be 4.5, so it's 23 times 4.5 plus that extra term there. That all works out to be 106.5 as the answer to the last part there. So yeah, a pretty standard recurrence relation and a little bit of sigma notation in there. Hopefully that all makes sense to you all.